Okay, today is the second day of solving rational equations, and we're not really learning anything new that we didn't learn last time. We're just going to keep reviewing the same skills and get more confident at it. As we've been doing this in class, the one thing I keep noticing is people are confusing adding and subtracting with solving. With adding and subtracting, our goal is to keep the fractions. We don't want to get rid of them. Solving, we're trying to get rid of them. So you're still looking for the least common multiple because that's what's going to help you. But in adding and subtracting, you want the denominators to become the least common multiple. In solving, we're going to use the least common multiple to clear the fractions. Okay, so looking at number 1, to clear the fractions, we need to look at the denominators. Because the only denominator is x plus 5, that's our only thing that we need to multiply by. So we're going to multiply each term by x plus 5, which looks busy, but it's going to help us because in the first fraction, the x plus 5 cancels and I get negative 4. Plus, in the second one, nothing cancels, so I'm going to distribute. 6 times x is 6x. 6 times 5 is 30. On the other side, the x plus 5 cancels, and I get negative 7x. When we solve, the first thing we need to do is combine like terms. So negative 4 and 30 is 26. So I have 26 plus 6x equals negative 7x. This equation is linear. I know that because the exponents are these invisible ones. So to solve a linear equation, I'm going to put all the x's on one side, all the numbers on the other, and then divide. So I'm going to subtract 6x from both sides. So I get 26 equals negative 13x. Divide by negative 13. And so I get x equals 2. Now I need to check. Does this 2 make any of the denominators 0? Well, if I plug in 2 here, 2 plus 5 is 7. No, that's not 0. So this is not an extraneous solution. It's good, and we leave it. Okay, let's try this again on number 2. On number 2, the only thing that's in the denominator is x plus 7. So I'm going to multiply each term by x plus 7. I do this because when I solve, not when I'm adding and subtracting, but when I solve, I want to clear the fractions. So these go away and these go away. In the first term, I'm just left with negative 7. In the next one, I've got to distribute the 6. So 6 times x is 6x. 6 times 7 is 42. Equals, everything canceled, and I just get x. First step in solving, combine like terms. So I get 6x, negative 7 and 42 is 35, equals x. It's linear because the exponent is the invisible one, so I'm going to get all the x's on one side and all the numbers on the other. So I'm left with 35 equals negative 5x. So to solve, I'm going to divide by negative 5, so I get x is negative 7. But now I need to check. If I plug in negative 7, will it make the denominator? The denominator, I don't care about the numerator, but will it make the denominator 0? Yes, it will. So this solution here is extraneous. So we're going to mark it by putting that ext next to it. All right, let's try this again. Number 3. Again, I want to solve the clear the fractions, and the only denominator I have is x plus 2. So I'm going to multiply each term by x plus 2. The first one, it doesn't cancel out, so I'm going to distribute. 2x times x is 2x squared. 2x times 2 is 4x. Over here on the second one, these cancel, so I just have minus 3. Equals, on this one, I'm going to distribute the x, so I get x squared plus 2x. The first thing to do is look for any like terms I can combine. I don't have any. So now I have to decide if it's linear or quadratic. It is quadratic, and I knew it was quadratic because I had an exponent of a 2. Anything that has an exponent of a 2 is considered a quadratic equation. So to solve those, remember our 3 steps. We're going to set equal to 0, factor, and then solve. Now, when I set equal to 0, I need the x squared to remain positive. So if I move the 2x squared over, I'd get negative x squared. I don't want that, so I need to move the x squared over, and I need to move the 2x over. So when I get done, 2x squared minus x squared is x squared. 4 minus 2 gives me 2x minus 3. So now it's set equal to 0. Now I need to factor. It's a green light, so I'm going to go straight to my two parentheses. I have an x and an x. The two numbers that multiply to negative 3 and add to 2 would be positive 3 and negative 1. So when I solve, x equals negative 3 and positive 1. Now I need to check. Do either negative 3 or positive 1 make my denominator 0? No, they do not. So none of them are extraneous. Both solutions work. Okay, let's try this again on number 4. Number 4, the only denominator I have is x plus 6. So that's what I'm going to be multiplying everything by. The first fraction, the x plus 6 cancels, and I get negative 4x. The next one, nothing cancels, but 1 times anything is just going to be x plus 6 equals, these cancel, and I get negative 9. First step, combine like terms. Negative 4 and x is negative 3x plus 6 equals negative 9. Now I look at this equation. Is this linear or quadratic? Well, there's no x squared, which means it's linear. We've got that invisible 1. So I'm going to subtract 6 from both sides. So I get negative 3x equals negative 15. Divide by negative 3, so x equals 5. I need to check, is 5 extraneous? Does 5 make either one of my denominators 0? The answer is no, so that one works. All right, 2 more problems. Number 5, I want to clear the fractions, but I need to figure out what I need to multiply by. Well, if I'm looking at my denominators, they're not the same. So when they're not the same, I need to find the least common multiple. But to find the least common multiple, everything needs to be factored. So the right-hand side, there's nothing I can factor. But x squared plus x, I can take out a greatest common factor of x, and I get x plus 1. That means that my least common multiple is going to be, well, there's 1x. This has 1x plus 1. This has 1. It's a tie, so I just have x plus 1. So now I need to multiply everything times that. So in the first fraction, the x plus 1's cancel. And so, oh, and the x, my bad. So I'm left with just negative 6. Plus, in the second term, nothing cancels. So I've got 1 times x plus 1. Well, multiplying 1 by anything is not going to change it. So it's, or if I could just said 1 times x is just x. So now I'm going to distribute this, and I get x squared plus x equals, over here, the x plus 1 cancel. So I get x times negative 6x, which is negative 6x squared. Okay, there's no like terms. So now I need to set it equal to 0 because it's quadratic, because I have the x squared. I need to keep the x squared positive, so I'm going to have to move this 6x squared to the other side. When I do that, I want to write it in standard form or descending order, so I have x squared, x, and then a number. So I'm going to get 6x squared plus x minus 6 equals 0. All right, I need to factor this, but I just realized that I made a mistake. X squared plus 6x squared is just not 6x, but 7x. Okay, so first step, set equal to 0. Second step, factor. So to factor, this is a trinomial. The leading coefficient is not 1. This is where we're going to split the middle term. 7 times negative 6 is negative 42. The two numbers that multiply to negative 42 and add to 1 would be 7 and negative 6. So now I'm going to rewrite it, splitting the middle term. So I have 7x squared plus 7x minus 6x minus 6 equals 0. Okay, now I need to solve by, or factor by grouping. What can I take out of the first two things? 7x. That leaves me with x plus 1. Minus, over here, I'm going to take out the negative 6. And when I take out a negative, it changes my sign, so it's positive x plus 1 equals 0. So now when I rewrite it, I get x plus 1 times 7x minus 6 equals 0. So when I solve, I get negative 1 and 6/7. Okay, well that's fine. If I look at this though, Now that I've got my answers, I need to see if any of them are extraneous. Well, if I put in -1 here, it's going to make my denominator 0. So -1 is extraneous. 6/7, even though I don't know exactly off the top of my head what it would be, is not going to make it 0. So this is extraneous. So I'm going to mark that, and that's what I want you to do in your homework. All right, one last one. I need to clear the fractions, so I'm going to look at the denominators. So the denominators are x plus 1 and x. So I'm going to multiply by the least common multiple, which would be x times x plus 1. All right, in the first fraction, the x plus 1's cancel, and I've got x times x, which is x squared. Over here, the x's cancel, but be careful because this is plus a -4, so now I need to distribute -4. So I get -4 times x, which is -4x. -4 times 1 is -4. Over here, the x plus 1's canceled, so I have x times -2x, which is -2x squared. All right, so now there's no like terms. And I know that it's quadratic because there's an x squared. So the first thing I need to do is set it equal to 0. And when I set it equal to 0, I want the x squared positive. So I'm going to move the 2x squared to the left side. When I do that, x squared plus 2x squared is 3x squared minus 4x minus 4 equals 0. Okay, I need to factor it now. I'm looking for a greatest common factor. There isn't one. It's a trinomial with the leading coefficient of 1, so I need to split the middle term. 3 times -4 is -12. I need two numbers that multiply to -12 and add to -4, which would be -6 and 2. So now I'm going to rewrite it, splitting the middle term. So I have 3x squared minus 6x plus 2x minus 4 equals 0. Now that it's 4 terms, I'm going to factor by grouping. So the first 2 terms, I can take a 3x out, and I'm left with x minus 2. Plus, out of the next 2 terms, I can take out a 2, and I'm left with x minus 2 equals 0. Write my final answer, x minus 2 times 3x plus 2. Okay, so first step was to set equal to 0. Second step is to factor, which I just did. And the last step is to write equations and solve. So here I get positive 2, and here I'm going to subtract 2 and divide by 3, so I get negative 2/3. Now I need to check. Plugging in 2 or negative 2/3, neither one of those is going to make the bottom 0, so neither one of those solutions is extraneous, and I don't have to mark either one.